Hey guys, welcome to EV Conversion Electronics, the couch sessions. In front of me I have the BMW safety box, the ZombieVerter, and I played around with it already and got it working, and now I'm going to backtrack and show you how I did it. When it comes to controlling the BMW safety box with the ZombieVerter, it takes two to tango. What I mean by that is that there's some hardware involved and there's some software involved. That's why I have the laptop out here in front of me. So we're going to start off by reviewing how to wire the Zombie. We're just going to keep it very simple. I purposely am not going to use the actual header and the connector that goes on here. I'm just going to wing it by connecting individual wires just to demonstrate to you how easy this is and how very few wires are required. So we are going to wire up the Zombie to give it power to make it operable. And then we're going to fire up the laptop, connect to the Zombie with the Wi-Fi. What we need to start off by doing is enabling some sort of a shunt, a current shunt. And in the software for the Zombie, we have three choices: disabled, ISA shunt, or the BMW safety box, S-box as it is called for short. So there is some stuff we need to do in the software, and there are some other additional parameters we need to set as well. And I'll show you how to do that. Okay, so we are going to start off with the very basics. So the Zombie has a 56-pin connector, and it's sort of grouped into two sets of 28, but they are numbered across. So if you are looking at it, it will be 1 through 28 and then 29 through 56, going like that. And to power this thing up, and this is hard for me to shoot this video because I don't really know where to put the camera. I'm going to start off like this, and then maybe I'll bring you over my shoulder. But as we start here, if it's facing you guys, the last two pins, 55 and 56, is how we power up the Zombie. Pin 56 is going to be positive 12 volts, permanent power, always on. Even when the car is sitting in your garage, the Zombie is getting some power. It's sort of in standby mode, right? And then pin 55 is ground. So I am just going to simply wire it with regular, I don't know what this is, maybe a 20 gauge wire, just whatever I had, just some scrap. And you know, I just happen to have some connectors here that will go on these pins, okay? These are left over from my truck project and my VCU for the Lexus GS450H. I don't expect you to have this. I'm just giving you an idea on how I'm going to do it. So, but one thing that I do that is very important is that when I crimp them on, I don't keep them naked. I will always insulate them. So I put shrink wrap on them. I think that's very important because they are very likely to touch, and this is a hefty investment, so you don't want to fry the Zombie. I'm doing this to demonstrate this to you. I'm not saying do this even on your workbench, okay? If I wasn't making a video, I would have a harness here with the proper connector with whatever wires I needed. But I'm trying to keep it simple to demonstrate just what is required. I know that if I laid out a 56 wiring harness on this coffee table, you wouldn't be able to see the coffee table. So I'm just trying to demonstrate this. So the black one here, I know this is pin 55, and it has shrink wrap on here, and it will just simply plug into pin 55. Simply, right? Not when the camera's rolling. I hope to show you close-ups as I edit the video. Okay. This is the ground. It's just the wire. It's just a freaking wire. So for the positive, I like to use fuses, okay? You don't need an alligator clip. but I do recommend the fuse. I like these guys, they're weatherproof. You know, inside the house, on the coffee table, it doesn't matter, but I also like to run them in the vehicle, so these are nice. 2 amp, just because I couldn't find a 1 amp at my local hardware or auto parts store. The same connector goes on here. You can use whatever fits, you know, because this is just temporary, but I do shrink wrap them, right? So shrink wrap connector and a fuse on the positive wire, positive lead. And that goes to pin 56. '55 and 56 and you're done, okay? Now we could bring out a car battery here and connect these to an actual car battery. I'm going to use a bench power supply just because it's a little bit more civil. Okay. I'm going to take the opportunity to talk about some tools, okay? Couple things I want to point out. This is a proper wire stripper. If you're a noob, treat yourself to this. I've done a couple wire harnesses. I still consider myself a noob. So this is a proper wire stripper. It will make your life a lot easier. This is not a real quality device. It's okay, but it's so much better than those that you kind of do this on and pull off the wire strip or put it in your mouth and use your teeth. We've all been there. But I want to show you some of these other tools is because these other tools are basically crimpers, if you will, but you need to build up a little bit collection of tools because not crimpers were created equal. And I'm not going to get into what these are, but if a crimper doesn't work, you're not the problem. It's just not designed for that type of connector. So you will need to buy, as you build wire harnesses, the proper crimpers, and it makes all the difference in the world. It's like screwdrivers. If you ever rebuilt a carburetor, you need to bust out every screwdriver you own, in my personal experience, to rebuild a carburetor, because for this screw head, you need this size Phillips, and for this one, you need this size flathead, and so on. You get the idea. And I just used a cigarette lighter for the heat shrink, okay? Okay, and finally, we need some sort of a power supply, either a car battery or this bench power supply. So this one here, I think, is 30 volts and 10 amps. Usually they're about 300 watts of power, and it's a combination of either 60 volts and 5 amps or 30 volts and 10 amps. You do the math, you get what I'm saying. So the nice thing about these is that you can set them at whatever voltage or whatever amps you want. It's one or the other and not both. So for this project, we don't want to exceed 12 volts, 12 nominal, right? So that's kind of like a in-name only term. We know that a car battery charges up to like 14 volts. I'll probably have this set to like 13, but I'll be referring to this as a 12 volt battery source, okay? So this is not a tutorial on these devices because there's guys who explain this stuff way better. Of course, my power strip is off. Okay, so hopefully you can see that it's set to approximately 13.2 volts, okay? That's what we want, and it will pull whatever amps it needs, but we will be using this as our power source. So at this point, I'm a little bit perplexed. Do I make this stuff face you guys, or do I have the camera on the side of me here? So we'll keep going until I feel like it doesn't make any more sense. Okay, so this is the black. We're talking about direct current DC, so this is color coded. Red is positive and black is negative. It changes when we get to alternating current AC, but for DC, we're good with that. So black to black, and just make sure these guys are not touching, right? All right, so we see one LED light is on and one is flashing. So this is zombieing right now. This is powered on and it's working. 2 wires. Pin 55 is black and that is negative, and pin 56 is red and that is positive. Yes, I'm gonna sound like a broken record throughout this video. One thing that I did there that I'm not proud of is that I don't like to move the zombie when these are plugged in like that, because I don't have the proper header on here. So I shouldn't be really moving it. I just lifted it so you guys can see. But even with these things, shrink wrap, just be careful and don't move it when it's plugged in. And also don't pull out wires and plug them in while this is hot. Just power it off and then add or remove wires as you need them. So the way we access the software on the Zombie is wirelessly. There is no need to wire anything to the laptop. We can use our phone, tablet, laptop obviously, computer, what have you. I think Chuck Norris uses an Etch-a-Sketch to program this. I'm not sure. Okay, so the first thing we want to do is go and look at our wireless networks. And because I have the ZombieVerter wireless network set up to automatically connect, it nicely already connected for me. I can tell that because it gives me the option of disconnecting. Well, we don't want to disconnect, we want to leave it connected. But like I said in a prior video, this laptop is dedicated for this project and it automatically connects to the Zombie's wireless network. Check this out. Network not found, network not found too. Guess whose home networks those are? Security through obscurity, baby. Security through obscurity. Okay. We're going to fire up a browser. I just happen to use Edge. Normally I just use Edge to download Chrome, but another thing that I did here is I set it to be my home page and to automatically pull this page up. Again, if you dedicate a laptop to this, then it's just all automatic for you. And there is no other clutter with other tabs and so on. So what we want to do is we want to go to parameters and we want to look for the section that talks about the current shunt. So under parameters, if we scroll down, there is a section that says ISA shunt control. This is essentially current shunt control, and as you can see, currently it is off. So what we want to do is we want to say on, because we want to start using a current shunt, and we also want to pick what kind. Well, it's inside of a BMW safety box. So I just realized that when I talked about the safety box outside, I mentioned it has contactors in it and a relay and a resistor, but it also has a current shunt. The current shunt senses the current that is flowing through the negative lead of the safety box. So we select the following settings, and now what we have to do is save them. So we go up here to the commands and we click on Save Parameters to Flash. So this basically says save your settings to memory. So we click on that. So now nothing happened on the screen. One of the things I wish this feature had and did is when we click on Save Parameters to Flash, I wish it would automatically jump you to the the parameters section, because there's a messages subsection here, and it shows you what it did. And can map stored, parameters stored, and then a CRC is some sort of a checker. But basically, it worked. So I just wish when we click on save, it just jumped us to this section. You can clear the message here and notice that message went away. And if we were to write again, let's see if it'll show us they were written again. There it is. Clear. So there you saw a glimpse of the save parameters feature. Okay, that's it. For now, that's all we have to do. There's some other parameters that we would need to change if we were in the vehicle, but for now this is it. I am going to mention one other just because we're going to be testing the safety box without a battery pack attached to it as we take baby steps through this. And I think there is a setting on here, I think it's under contactor control. So here we go. This setting, I just have it set to 0 because this setting says at what voltage do we want to close the main contactor. Usually the main contactor refers to the positive contactor. So the way the system works is when you get in the car and you turn the key onto ignition and then you press start, you close the negative contactor and you close the pre-charge relay, and then the voltage starts flowing and building up inside the inverter capacitor until it senses that it's at this voltage, whatever we put in here. So if we're running a 350 volt battery pack, we would set that to maybe half of that, something like 175 or 150, you know, somewhere in there. You can set it up to 200, whatever you want. Maybe that is going to be too high, but set it to about half of your voltage. We have it set to 0 because we're not going to be using a battery pack. We're not going to be using any type of power source on that safety box just for testing. So UDC SW needs to be set to that. I think this acronym, the U stands for either a German word or a Latin word. DC is direct current, and I heard Damien refer to SW as switch. But basically this is the voltage at which point the system goes full on and supplies all the power to the inverter. So this is a important setting. For our test, it's at 0. Okay, and that's it in the parameters. We may come back to this later in the video, but for now I wanted you to focus on enabling the current shunt and choosing which one you have. Okay, so next what we need to do is we need to wire up the BMW safety box. I mentioned earlier that there's 5 wires coming off of it. We're going to start off with the black negative lead. So that simply will connect to the negative on our bench power supply. At this time, it's worth mentioning that the safety box has 2 types of electric paths or circuits on it. The orange is the high voltage, and then this is the low voltage. So it's not dangerous right now because there is no battery pack connected. I don't need these orange cables on here. I left them on here because this one is zip tied, and then they're a bit of a pain in the butt to unplug, and I just didn't want to remember where they go, so I just left them on there. But this is safe to touch. There are no capacitors in here. There's a circuit board, so there might be tiny little caps, but nothing big and major. And it's not connected to a battery source, a high voltage battery source. So we don't have any high voltage going through it for this test or need any. We're just worried about the low voltage side. So then it has not one but two red wires, and those are going to be our positive lead. And anytime we connect the electric component, we put a fuse on it. I put the fuse on the positive, on the red wire, and that will just connect to the bench power supply as well. So we just took care of three wires, a black one and two red ones. And then that leaves us with the CAN bus, okay? So these wires connect to the Zombie. So here's our Zombie. I like a clean canvas, so I disconnected our pin 55 and 56 that we're familiar with. Okay, great. 56 pins to choose from, 54 technically, we eliminated two. Where does this connect? Well, the Zombie supports three different CAN connections, or channels if you will. CAN 1, CAN 2, and CAN 3. So which one of those three do we connect to? Well, let's find out. So I mentioned that the Zombie supports up to three cans. Is that what we say? Cans? Sure. And we go back to the software interface and we're going to see if we can find them. So here we go. Most likely they're under settings, which are called parameters. And we start looking under general setup. Okay, inverter, vehicle, transmission, blah, blah, blah. Oh, inverter CAN. Vehicle CAN, shunt CAN. Hey, interesting. Limb CAN, charger CAN, BMS CAN. Okay, shunt CAN, that's what we want. And it is on CAN 1. Okay, so it's on CAN 1. We can change it from CAN 1 to CAN 2, but do we really want to mess with it? We're not going to mess with it. We're just going to keep the defaults. By the way, although there's CAN 1, CAN 2, and CAN 3, not all CANs on the Zombie were created equal. So CAN 1 and CAN 2 are like the major ones, and CAN 3 is sort of like the orphaned one. I don't want to get into that one because I can't explain it. I just know that I think they're driven by different processors on the board. So that's why when we click on here, we only see a choice of CAN 1 and CAN 2 and not all the way up to CAN 3. Whereas maybe trying to see if any of these will actually go up to CAN 3. Anyway, that's neither here or there. There's three CANs and 1 and 2 are similar. The third one is a little bit different. And we're just accepting the default settings. But what we've learned is that for the shunt, the current shunt, the CAN is CAN 1. Okay, well that's half the battle. We know what CAN 1 is. But now, which pins are dedicated to CAN 1? Let's find out. Okay guys, I need to confess here. I'm going to be a little bit of a hypocrite here and use this laptop to get onto the internet, although I said dedicated to a project. And the disclaimer being that I only paid for one license of this ice cream screen recorder, and I really don't want to buy a second license to put on another machine just to occasionally jump on the internet. But I don't want to just tell you how to do things. Basically, I want to teach you how to fish and not just give you a fish, right? So what we're going to do is we're going to try to find some more information on the ZombieVerter, and it's incredibly well documented, so you just have to know where to go. Now let's go to Open Inverter. Okay, so I guess if we go to openinverter.org, it takes us to the main page of the wiki, and that's where we wanted to land, okay? But the key word being Open Inverter. So Open Inverter comes from open source. So this was developed by Johannes Hubner, and he created a wiki page for it and a forum and so on. but it's basically him sharing his and other reverse engineers' amazing work in allowing us to use electric car components and hybrid car components outside of those vehicles in our DIY EV conversions. So we come to the main page and we want to find something on the ZombieVerter. So we're going to type in the search ZombieVerter, let's say VCU. I already had it in there because I've been there 1,000 times, but I'm just showing you how to get there. Some of this stuff is overwhelming. You know, when I was first looking at this a while back, I was like, okay, this is just so much information. But keep at it, and it's really starts making more and more sense and kind of becoming second nature where to find things. So we are on the ZombieVerter VCU page, and I'm just going to scroll. We're looking for the pinout, and bam, there it is. Okay, cool. It's kind of looking familiar. I mean, we were talking about 56 pins, so up here we can see this has 56 pins on it. We can see that it's kind of split into one connector here and the second half of that connector here. Okay, cool. Well, we're looking for something called CAN. We need to find CAN 1. Alright, well, if we start with this one, look at there. There's a CAN external 2, L for low, CAN external 2 high. Okay, throttle, whatever. Ooh, more CAN stuff here. There's CAN external 3, CAN external 3. Remember how I told you there's 3 CANs? Okay. Well, what's this? This one says CAN external low, CAN external high. But it's not, doesn't have a number. Well, I'm going to guess that this is CAN 1, okay? Now, worth mentioning that in the code, usually they refer to CAN 1 as CAN 0 because it's sort of like numbered like an array. And then in the code, CAN 1 would be actually CAN 2, and in the code, CAN 2 is actually CAN 3. If I confused you, good. Don't worry about that. Just what we need to know is that it's this box and this box, which if we follow this arrow to this connector are up here, so this would be 27 and 28. Okay, cool. So it looks like they're right above our buddies 55 and 56. All right. And CAN external low, there's 2 signals, low and high. Low, I remember my low on here was that black purple wire, and my CAN high was that yellowish wire. Okay, well that's what we needed. Now we're going to go and make the connection. Okay guys, I know we're kind of jumping between the software and getting out on the internet to get more information and doing the hands-on, but this is kind of how it works, and I just don't want to show you or just tell you what to do. I want to show you where the information comes from, okay? So we have already connected the black and red wires to our bench power supply, okay? It's turned off, but they're connected. If we were to turn it on right now, nothing would happen, okay? That thing gets power, but it doesn't have any LEDs, doesn't make any noise, it doesn't wiggle, it doesn't spin, it doesn't do anything, okay? So we need to give it some intelligence. Okay, so we grab our twisted, 2 wires that are twisted here, the twisted pair, which we know is CAN. Anytime we see twisted, that's most likely CAN. And we know that it's numbered across, so from 1 all the way down here to 28. So it will be 27 and 28. So do we remember what it was? 27 was low, CAN low. Again, CAN is just 2 signals, low and high. So we will put the darker wire, the purple or the black and purple, that is our low, and then 28 is high. So the yellow is the other one. And that is our connection to the safety box. 2 wires, that's it, okay? So I purposely removed the power to the VCU just to make this more obvious and clearer to identify. Of course, we have to reconnect those back in to power on the VCU, and I'll do that next. Let's review. We have our 56-pin connector. First thing we're going to do is connect the power for the Zombie. So we have the positive is on pin 56. And you know, sometimes I'll connect the ground first, sometimes the red wire for 12 volts. It doesn't matter, obviously, but ground is 55 and the power is on pin 56. And then what else we need on here? Well, what we just talked about, we need our CAN. This is the CAN 1, and it's how we're going to talk to the safety box. Now, worth mentioning that CAN is, what's nice about it is it can be daisy chained. So we don't need CAN 2 for a second device and CAN 3 for a third device and CAN 4 for a fourth device and so on, and use up more and more pins. These 2 pins can support 10 devices on them, maybe 20, you know? So now we will connect the CAN here, and then so on pin 27, we have the CAN low. And it's important that the low goes to low and high goes to high for this to work. So we have to get those right. Okay, so 4 wires. All right, let's test. Let's see what happens. So we need to connect the power. The power supply is off, so I'm just making these connections, just letting you know. I'm going to untangle this a little bit. Then we have the ground from the VCU, and we have the ground from the power supply. Now you don't have to twist these together, it's just something I do just to ensure they don't fall out of the little alligator clip, okay? So both negatives, negative from the safety box, negative from the Zombie, go to the negative here. Again, apologies for being repetitive in this video, but I'm trying to make sure that we all get this right. Okay, and then we have the red leads from the safety box and fuse on those as well, and those will go to the positive here. So it's a little hokey with these alligator clips. I'm going to get a little bit nicer, I guess, test setup with a bus bar, but for now, I'm working with what I have. Okay, so now if we turn this on, the Zombie is on. This thing is getting power, it's not doing anything. Okay, so what do we do? I mean, do something, right? It's not doing anything. Okay, so we have it all connected, but nothing is happening. So let's fire up the laptop and take a look at the software and see if that tells us anything. Okay, so we want to go to parameters. I'm going to start a recording session. I'm going to see if I can do both. Video myself and record myself and see what kind of mess we can make. Okay, so we fire up the software. We're going to jump to spot values. We're going to spot values because that is feedback. That is telling us something. Okay, so under spot values, we see version. Okay, we know what version we're on, whatever. Then there's something called op mode, and it's set to off. So this is operational mode, and it's off. Well, there's a couple different modes we can be in. Okay, one mode would be charge mode, charging. Well, we're not charging. We want to drive essentially. So we want this op mode to be either like on or run, anything but off. So what do we do? Okay, well, we need to wire up more stuff on the Zombie, okay? Yes, it has 2 wires for power, and then it has this CAN talking to the safety box, but the Zombie itself needs more than just 2 wires, okay? So I jumped a little bit ahead here, but it doesn't matter. We're going to backfill with the other information. Okay, so let's go over to our pinout. And what we need is ignition, okay? I just jumped here because I already knew about it, right? But it's ignition, and if we follow our little arrow, it goes to here, and it's this top box, and it's 15. So it's actually says ignition T15 in. Okay, so we need to make some sort of a connection here. Well, what is this ignition thing? Well, it basically tells us that pin 15 also needs 12 volts, okay? That's as if you got in the car, and if you have an older car, I should say, you turn the key from the off position to on. That's what ignition is, okay? So let's do that. We need to add a wire here to pin 15. All right, so first thing we're gonna do is we're gonna shut this off because we know not to mess with this when it's on. We don't wanna unplug any wires and we don't wanna plug any in just because we have this hokey setup going, right? So we're gonna turn this off. Okay guys, so I wanna talk about this next wire because I put a switch on this wire, all right? Because this is, again, you get in the car and you turn the key to the on position. So instead of turning a key, I'm just gonna click on, right? And you don't need this. You can just alligator clip it as long as you have a wire. So I'm just using a different color so I don't get confused. Colors don't matter. I'm using white on here. I also shrink wrap my little connector so it doesn't touch any other pins. And I'm just going to simply put this on pin 15. Okay, it's on pin 15, and then this end here has to go to my 12 volt power. I apologize because this is beginning to look like spaghetti, I know. Okay, so although I connected that wire, it's not on until we click it to on, okay? Also, I think either a 1 amp or a 2 amp fuse on that. All right, here we go. Let's test this now. So I do turn off my power supply off and on, but just pretend that's permanent power. Just pretend that is always on. So, and by permanent power, I mean to the VCU, not to the safety box. The safety box will get its power when we turn on the ignition. So I just don't have it wired that way right now because that's kind of not the point, but permanent power to the VCU means always that power is always there, okay? Then now I turn on the ignition. So let's go back to our software. But permanent power is on. We've added an ignition wire on pin 15. That is our key on. All right, let's turn the key on. Okay, nothing changed on our screen. Operation mode is still off. Well, we've learned about the refresh button, so let's click refresh. Shoot, still nothing. Okay, still nothing. The safety box is not doing anything. We're still in off mode. What else do we need? Okay, let's jump back over to our pinout. And you wouldn't learn about it the way I'm doing it here, okay? I've watched Damien's videos, I've read up on stuff, I talked to friends. Big message to you guys: network, network, network. Make friends, ask questions. People are willing to help you out. So there's the forum, Open Inverter Forum. That's where information lives. So I gathered all this information, I pieced it together, and here I'm sharing with you in one video, hoping to pull this off. But I'm also kind of building on the knowledge, right? We get power to the VCU, then we give it ignition, and then we need one more component. So hang in there. This is the last thing we need. So if we look over here on this pinout connector, we have permanent 12 volts, which we're using. We have ground. Then there's direction. Okay, forward and reverse. Okay. What else is there? Ooh, there's a start. Okay, there's a start, and it's 1, 2, 3, 4, 5 pins over. So let's go up on this arrow to here. 1, 2, 3, 4, 5. Pin 52. Ooh, pin 52 is very important. That is ignition start, or ignition run, I guess. So if you put the key in the ignition, you're in off position, you turn it one click, that is on, but you're still not going to drive the car. You have to click it and then release. It's a momentary switch. That's for the starter. It starts your engine. But as soon as it starts the engine, you let go of that and you're no longer in that position, okay? So this is a momentary start. So for that, we're gonna need another wire. All right, guys, so we need another wire. We need to add this to our Zombie, okay? I chose pink. I come from General Motors world, GM, Chevy, Bowtie. I like all kinds of cars. I don't think Chevy's better than Ford or vice versa, any of that. But I'm saying it because they like using pink for ignition, key on power, okay? So red is permanent power, and then they use ignition, pink for when you turn the key on. So I'm just gonna use pink. And this has to go on the pin 52, and this also now has a momentary switch. So I don't know if you can see this, but this is just like a button, you know, I push and a spring releases it. That's going to simulate us turning the key all the way to the right and like letting go of it. So first thing, we're going to turn this off. Okay, we're doing this dingleberry connection wiring harness, so we have to be careful. And that was 5 over, so 1, 2, 3, 4, 5. Get in there. All right. Sorry, I forgot the power for this guy. Let's connect the power. So that's pin 52. This start thing is also 12 volts, but it's not permanent, and it's only momentary. Okay. So I have a switch on it. All right, also a 1 amp fuse on that. 1 or 2, whatever I happen to have. Okay guys, so let's test this. I'm gonna start off by bringing up the software. Okay, so I'm doing a screen recording of that, so don't worry if you can't see it on this camera. Okay, so first thing we do is we turn on our power supply. This simulates permanent power. This is how we would find the VCU if we just walked into the garage and just approached the car. This thing would already have permanent power. Then we get in the car and we turn the key to the on position. So this toggle switch simulates that. If we refresh our screen, that does not change the operational mode, okay? It doesn't change it. So then we further turn the key to the start position. Did you guys hear that? Let's refresh this. Check it out. Our operation mode has changed to run. Now we are in the run mode. So for the operational mode, it could be off, it could be run, it could be charge. Okay, if we're charging the battery. We are in run mode right now. And the safety box click. That's what we want. Now watch what happens when we turn off the ignition. Did you hear that? I know my switch clicks, but the safety box clicked as well. Let's refresh the page. Look at that. We're in operational mode of off. Okay, so something important I want to talk about here. Normally what would happen is when we push the start button, we would hear 2 clicks, or at least in theory we should hear 2 clicks. First click being the negative contactor closing. After that, the pre-charge relay closes and clicks, but it's a very faint click. I doubt we would hear that one. But after the voltage rises and it reaches our setting, a predefined setting of that UDC SW, right, under contactor control, then the positive contactor closes and we hear a second click, okay? Now, I say maybe that's in theory because we're dealing with electricity and it is lightning fast. So to get this thing up from 0 volts to 150 volts, it's a blink of an eye, a thousandth of a blink of an eye, right? So we might hear kind of a double click, like a reverbed click or something like that. And I know I'm sounding silly trying to explain this right now, but if you try to manipulate these contactors one by one, just saying close the negative, click, close the positive, click, it's definitely 2 distinct sounds, right? When we turn it off, when we turn our ignition key off, we kind of hear that simultaneous double clicking because both contactors are clicking open, releasing their connections, if you will. The reason I know that we're just simultaneously clicking in the on position because our under contactor control, is that where it was? Our UDC-SW is set to 0, okay? For testing purposes, that's what it's set to because we don't have a battery pack. But we've achieved our goal. Our goal was to make that safety box click, okay? If we wanted to geek out further, it could get a little bit potentially dangerous if we were to drag a battery pack into this living room and connect it to these wires. I'm sure we could. But even then, I don't think we would hear that distinct second click because it would happen so fast is what I'm trying to tell you. But for now, we know that we turn on the ignition key to on, the mode doesn't change. We press the start button, the mode changes to run. It initiates the starting sequence with our shunt there. It first closes the negative contactor, closes the pre-charge relay, starts building up voltage through the resistor into the inverter capacitor. Once it hits our preset UDC-SW here, ours is 0, but in the real car it'll be like 100 volts, 150 volts. Then it closes the positive contactor, okay? I hope you guys followed all that. You can feel free to rewatch the video. I will be the first to admit that Damien videos are incredible, and I've watched them all dozens of times, and every time I've learned something new. I've noticed something new. The first time I watched his videos, I doubt if I understood 1% of what he was talking about. Not because he doesn't explain things well. He is an incredibly well-spoken person, an incredible engineer, and a great instructor. But there's just so much information if you are new to this that you have to watch it a few times. Watch it, walk away from it, come back later, watch it some more. You know how to learn. So anyway, guys, I'm rambling, but I have a video to edit. Thank you so much for watching. I hope this helped you guys out, and I'll see you in the next video.